Well, you have definitely booked a ride on Uber, searched for nearby petrol pumps on Google Maps, or seen your friend's live location on Snapchat, right? But have you ever wondered what common concepts powers all these location-based features behind the scenes? That particular concept is called geohash. Geohash is a technique that divides the world into grid of rectangular cells and assigns each cell a unique alphanumeric string. So it's like giving every region on Earth its own short address. Now you might be thinking, but wait, don't latitude and longitude already give unique addresses for the locations? Actually, that's true. Latitude and longitude do represent precise locations, but GeoHash offers some technical advantages, especially when it comes to spatial indexing, clustering nearby locations, and performing efficient queries in database, which is why it's widely used in many real-world applications. We'll dive deeper into how GeoHash compares with latitude and longitude in another video. For now, let's jump into what GeoHash really is and how it works and power apps like Uber, Google Maps, and Snapchat. GeoHash was invented by a scientist named Gustavo Niemeyer in 2008. Now let me give you the simplest possible definition of GeoHash. GeoHash is a way of dividing the world map into small rectangular grids and assigning each grid a unique address made up of letters and numbers. That's it. Okay, now let's understand this with a real world example. If you want to represent India on a map, its address would be simply India, right? For Haryana, the full address becomes Haryana, India. If we go deeper, then Gurgaon's address becomes Gurgaon, Haryana, India, right? Now, even more specific, if we want to locate a particular sector, for example, sector 56 in Gurgaon, then its address would be sector 56, Gurgaon, Haryana, India, right? So, do you see the pattern here? The more precise the location, the longer the address becomes. This is exactly how GeoHash works. So, if you divide the world into fewer grids, each grid covers a larger area, so the GeoHash representing it will be shorter. But if you divide the world into smaller grids, each one covers a more precise area, so the GeoHash length becomes longer. So some of you might already be getting the hang of it, and if not, don't worry. Let's now get our hands dirty. We'll divide the world into grids step by step and generate the geohash for each and every grid. Let's do it. Now, this is our 2D world map. Okay, so in our globe, longitude lines run vertically. So they will be measured east to west. Therefore, they are plotted along the x-axis. And latitude lines run horizontally on a globe. Okay, so they will be measured north to south. Therefore, they are plotted along the y-axis. Therefore, x denotes longitude and our y-axis denotes latitude. Also, for this 2D world map, the longitude and latitude for top right is 180 and 90. For top left, minus 180, 90. Okay, so for bottom left, minus 180, minus 90. For bottom right, 180 and minus 90. These are the rules that we have to follow. So for latitude between minus 90 to 0, we'll denote it as 0. 0 to 90, we'll denote it as 1. Longitude between minus 180 to 0, we'll denote it as 0. And longitude between 0 to 180 will be denoted by 1. Okay. Now to form geohash of this world map, our first step is to divide the world map into equal parts by drawing horizontal and vertical line. Okay, so let's divide this particular world map by drawing a horizontal line and a vertical line. Okay, now this particular first quadrant, what is our longitude? 180 and latitude is 90. So 180 longitude is denoted by 1 and latitude 90 is denoted by 1. So address of this particular block first quadrant will be 1 1. Similarly for second quadrant, minus 180 longitude denoted by 0 0 and 90 is the latitude. 90 latitude is denoted by 1. So 0 1. This will be the address of second quadrant. For third quadrant, minus 180 minus 90. Minus 180 is 0. Minus 90 is 0. So address will be 0 0. For 180 minus 90, fourth quadrant, 180 is 1 and minus 90 is 0. So address will be 1 comma 0. Okay. So we can write for after dividing this world map into 4 parts, top right address is 1 1, top left address is 0 1, bottom left address is 0 0 and bottom right address is 1 0. Okay, now our second step is to keep following this first step again and again. Okay, so let's again keep on dividing the world map into equal parts. So let's take this first quadrant and divide it into equal parts. Okay, so let's again divide it into 4 equal parts. Now what will be the address of these 4 quadrants? Okay, so for example, see on top right, this is India's map, right? This is India's map. So address of this map is India. Now if we divide this map into smaller parts, suppose this is Haryana, so address will be Haryana comma India. If we take here Gujarat, address will be Gujarat comma India, right? If we take Goa, address will be Goa comma India. Okay, so the broader part, the bigger part address is in the suffix, right? And that is constant for all the subparts which we have divided. Okay, so prefix is different for each and every subpart of this map, but the suffix is same, which is the address of the bigger portion of the part. Okay, so let's follow this same thing in this first quadrant. For this first quadrant, the suffix of address of all these smaller parts will be same, will be equal to 1 1 1 1 1 1 1 1. Okay, just like this India, right? So suffix is same. Now what is the prefix? Okay? What will be the prefix of all these 4 blocks so that the address becomes unique for all the blocks? Okay, so when we divided our world map into 4 parts, at that time top right was given 1 1. Okay, now forget all these 3 quadrants, and if we consider only this first quadrant, it is again divided into 4 parts. Okay, so this top right, we can again label it as 1 1 from here, right? So let's label it as 1 1. For this first quadrant, this particular block is top left. It was labeled as 0 1. So let's label it as 0 1. This is for the first quadrant, this block is bottom left. So let's label it as 0 0, just like here. And this last is bottom right. So let's label it as 1 0. Okay, now these are the unique addresses of these 4 blocks. Similarly, you can do it for second quadrant, third quadrant and fourth quadrant. Okay, now let's go one step deeper and divide this block into 4 parts. Okay, let's divide into 4 parts again, vertical and horizontal, right? What will be the suffix? Suffix will be the address of this broader part, which is 0 1 1 1 0 1 1 1 0 1 1 1 and 0 1 1 1. Now what will be the prefix? So it is top right. So since it is top right, it will be 1 1, right? This will be 1 1. This is top left. This will be 0 1. This will be 0 0 and this will be 1 0. Okay, so for this smaller block, the geohash will be 0 1 0 1 1 1. Okay, so This is what you do in GeoHash. You keep on dividing the world into smaller parts, small equal parts, and then assign them the corresponding address the way I have shown you. Okay, cool. Now suppose we kept on dividing this world map into smaller parts, smaller parts, smaller parts, okay, and we reached out to this smaller piece of block here, okay, and assume that our geohash comes out to be 10010110111011101. Okay. Now since our geohash should comprise of letters and numbers, let's convert this binary geohash to alphanumeric. Okay, so here the numbers we will use from 0 to 9 and alphabets from A to Z. Okay, so for 10, just like in hexadecimal, we'll use A. For 11 we'll use B, for 12 we'll use C, for 13 we'll use D, for 14 we'll use E, and so on. Okay. Now the third step is to form group of 5 bits of this binary geohash. So let's form group of 5. So this is our first group, 1, 2, 3, 4, 5. This is our second group of 5 bits. This is our third group of 5 bits. Now since 1 is alone, let's put 4 zeros in front of it, and this is our fourth group. Okay. Now the fourth step is to convert these groups into the decimal representation of binary. Okay. So what is the decimal representation of this binary digit? It is 13, right? And this also 01101, it will be equal to 13. This will be equal to 001015, and this will be equal to 1. Okay, now 13 what we have to do? 13 replace it with D. This also replace it with D. This 5 will remain 5 and 1 will remain 1. So final geohash will be 15DD. So for that particular small piece of block, the final value of geohash is 15DD, which is a 4-letter geohash. Okay, so this is how you generate geohash for any block in this particular world map. Got it? So as you can see, if I keep on dividing the blocks further, the blocks keep on becoming smaller and the length of binary geohash will increase. And when the length of binary geohash will increase, this will in turn increase the length of our alphanumeric geohash. Okay, so we can clearly say the size of block is inversely proportional to length of geohash. Now, if you see, we keep on forming blocks and every block will have some width and height, right? So suppose we form this block, this will have some height and width, right? Some small block here, even this big block, right? So every block will have width and height. Now what happened was, scientists and researchers, they kept on dividing the world into small parts, and using the method which I showed you, they calculated value of geohashes. And they found out that if geohash, in this table if you see, if geohash is of length 1, it denotes a cell with a width of 5000 kilometer and height of 5000 kilometer approximately. Okay, so geohash of length 1 will denote a very bigger block in which height will be 5000 kilometer and width will also be 5000 kilometer. Okay, so similarly for geohash of length 2, the width will be 1250 kilometer into 625 kilometer. Okay, so our length of geohash was 4. So our geohash must be denoting a cell whose width is 13.1 kilometer and height is 19.5 kilometer. Okay, so if we keep on dividing it, when you reach a geohash of length 12, the width comes as small as 37.2 mm and height comes to 18.6 mm. It is almost my fingertip. So geohash can be so precise, right? Now, while solving use cases like Uber, Snapchat, and all those real life problems which we get in these different kinds of apps, generally speaking, we use geohashes only till 6th and 7th. So beyond that, we generally don't require it. We use only till 1 to 7. Okay. Now let's do an observation here. Okay, so if I take this particular map, okay, you can see these two blocks are nearby, right? These two blocks are nearby, and since these blocks are nearby, they are sharing a common suffix, right? So even if I divide this block further, this will have suffix of 01011, right? This block will have 0101111. Again, these two blocks are very near, right? And they will also share a common suffix, right? Okay, so what I can say is, if two geohashes G1 and G2, they share a common suffix, that means those blocks are nearby each other, right? So if there are two blocks having geohashes G1 and G2 and both share common suffix, then that means those blocks are nearby, right? Now can we say the opposite? So can we say if two geohashes does not share a suffix, that means they are far away? Is it true? Actually, it is not true. Why? Consider this example. So our world is actually round, right? For geohashing, we converted our round world into a 2D map. Okay, so basically what we did was we opened the globe. Okay, so suppose these 2 points, A1 and A2. So if we see in a globe, both this A1 and A2, they are very near, right? But as soon as we open them to make a 2D map, A1 lies this side and A2 lies this side, right? Now if I try to divide this world and make geohashes, right? So this lies in second quadrant and this A1 lies in second quadrant and A2 lies in fourth quadrant. So A1 suffix will end with 0, 1 and A2 suffix will end with 1, 0. Okay. So this will end with 0, 1 and this will end with 1, 0. So you can see in reality A1 and A2 are very near, right? They are very near. But when you write geohash of those 2 points, they do not even share a single common suffix, right? Suffix ends with 1 and here suffix ends with 0. So they do not even share a single suffix here. So we observe that even though the geohashes of these 2 points do not share a single common suffix, still these points are actually very near when we consider it in a globe. So we can say they do not share any suffix, still in reality they are very near. Okay. So we can now write two very important properties of geohash here, which is actually used when we will design Uber and other stuffs. Okay. So what is the first property? First property is if G1 and G2 has common suffix, that means blocks are nearby each other, right? And second property what we can say is if G1 and G2 do not have common suffix, that does not imply blocks are far away in reality. Okay, so these two are very important properties and I have told you the logic behind this, why the suffix are different. Okay, now one last thing. So I have used 0 and 1 to divide our map, right? So I took our world map and I used 0 and 1 to divide it. I put 0 1 here, 1 0 here. Now instead of 0 1, you can also use any letter whatever you want, whichever symbol, whichever character you want. Okay, so suppose you use A, B, C and D. Okay, so you took this 2D map and instead of 0 1 you put A, B, C, D here. That will also work, right? So further when you go on dividing, keep A here and then A, B, C, D, right? You keep on dividing, keep A here and A, B, C, D, right? So this is also one address. This is also one address of the block. You just have to form another formula for this, how you will combine these AAA to 1 length, 2 length, 3 length geohashes. Okay, but you can use any letter, any variable that you want. Okay, now let's go ahead and look one website for visual representation of geohash. Okay, so this is our website, geohash.softeng.co. Here instead of using 0 1, they have used 0 1 2 3 0 to 9 and A to Z, all the letters, while dividing it at first time itself. Okay, that is what we discussed just before, right? You can keep on using any letters, any symbols and just make a formula out of it for yourself. Okay, now if I click this particular section, so you see the geohash for this is S. This particular block, the geohash is S. If I click this, the geohash is SM. If I click this, the geohash is SM4. Okay, so the blocks keep on decreasing and the size of blocks keeps on decreasing and geohash length keeps on increasing. So if I click this block, okay, geohash is SM4M. Now E this, M this, E, N. So I keep on clicking, it keeps on increasing. Okay, so now you can see this geohash is of length 3 4 5 6 7 8, and in reality if I zoom out, see length is 8 and I mean we cannot even see this point. This is very small, right? So suppose if you go till 12 length, it will almost denote mm that we saw in that table, right? So this is how geohash works and this is the visual representation of it. So I hope you find this video useful. This is very important while creating any apps that uses maps. Okay, so that's it for this video. Until the next video, stay safe, stay healthy. Bye bye.